Hello, Matilda. I understand you recently took a pre-calc course and are now wondering whether or not you would like to take the calculus course in your coming semester. Well, since I'm in a calculus course now, I decided I'd just give you the little spiel about what it's all about, starting off with talking about what exactly is a derivative. To learn about the derivative, we first need to examine a couple of terms. The first term is local linearity. So local linearity is the idea that any curved graph or any graph's curve will appear to be linear if it is zoomed in enough. So these two are actually pictures of the same graph. The one on the left, this one, is just really zoomed in at this point on this picture. So basically, if you zoom in on a curve far enough, it will appear to be linear in that locality. The second couple terms that you might want to think about are secant versus tangent lines. I have a nice visual up here. As you can see, the secant line is a linear function that intercepts with this curve in two places. Well, the tangent line is also linear, but it only intercepts with the curve in one area. And that is a very big part of this idea. So what is the derivative? Put simply, the derivative is an equation that provides the instantaneous rate of change or slope at any point in another equation. So if you have the derivative of an equation and you plug in the same x value, the derivative will give you the slope at that point on the other equation's curve. So how do you find this? To find the derivative of an equation, you put your equation into the limit definition of the derivative, which is a formula that helps you find your second equation. It comes from the slope formula. As you can see, it has the same basic shape with your y2 minus y1 over the change in x. The biggest difference is between this and the slope formula is that when you use the slope formula, you it's usually used for a linear equation. So it will give you like a secant line if you use it on a normal curve. So what you're looking for when you're trying to find the slope of a curved line is the instantaneous rate of change. And because there wouldn't be a second change in x on the bottom if you were to use the slope formula. So with this formula, the h represents the change in x, which doesn't exist because there is no change in x. And so you have to, instead of just plugging in values, you have to use algebra to find a new equation that will give you the value of the instantaneous rate of change. Here's how that works. This is for the function f of x equals x squared. So here's how it starts. You have f prime of x equals the limit as the change in x, which is either noted as delta x or h, approaches 0. So here's the limit definition that we looked at in the last slide. And then you plug in x plus delta x into the equation. So here's the first term, which is x plus delta x squared, and then minus x squared over delta x, because there isn't a second term, as we're just looking at an instantaneous rate of change, not the rate of change between 2 points. Moving down the list, it continues and expands and then reduces until finally you find that the derivative of the equation f of x equals x squared is 2x. And this equation, if graphed with the derivative, looks like this. So this is the quadratic equation, f of x equals x squared, and the black line is the derivative, which is 2x. So if you plug the same x value into these, you will find the black line's y value will give you the slope at any point along this green parabola. Thank you for watching my presentation, and I hope this sways you towards taking a calculus class this coming fall.